Alright guys, welcome to our channel Code with Sunny, and in this video I will be talking about a famous problem, palindrome partitioning, and it is second type. Okay, and its index is 132 and it is categorized as hard problem in the LeetCode. Okay, so this problem is actually a standard problem. We can do this like you can find a lot of resources talking about this problem. Okay, but here we are going to have the same condition, and I will explain in a simpler way how to build up the idea for this problem and what could be the best way to write down the solution to this problem. Okay, so without wasting our time, let's move further to understand the problem description. Given a string s, and we have to partition s such that every substring of the partition should be palindrome. Okay, so we need to divide the string right into multiple substrings such that every substring is going to be a palindrome. Okay, and we need to return the minimum cuts needed for a palindrome partitioning of s. Okay, so what this actually problem is what this problem is going to signify is like we have some string like s1, s2, and s3, s4, let's say up to s5. Okay, and we need to partition this string into multiple substrings, like we are going to do like that. Then this is one of the substring, this is another substring, and this is another substring, right? And we need to do that, and the cuts that I am going to perform, you can see this is one of the cuts. Okay, and this is also one of the cuts. So there are two cuts that I am going to do right now. And if you are if you are performing, if you are dividing the given string into multiple substrings, you need to ensure that whatever the substring that you are going to take, like this s1, this s2 and s3, and this s4 and s5, these all strings must be a palindrome string. Like s1 should be palindrome, s2, s3, sequence of characters, string going to be formed from s2 and s3 must be a palindrome, and similarly s4 and s5 must be a palindrome. Okay, so there can be multiple characters, let's say we have some. Okay, s1. Okay, so let me do this type. Okay, so we have s1, s2, s3, s4, s5, and s6. Okay, suppose we have this type of string, there can be multiple partition like this one, this one, this one, this one, this one. This is the worst case of partition, where you will have the answer as string length -1. This is the minimum number of cuts that you are going to do, and this will happen when all the characters are going to be distinct. Okay, so overall what you have to find is you have to find out what is the minimum number of cuts that you are going to perform, so that after you have performed the cut, every substring that you have extracted it out must be a palindrome. This is actually a palindrome partitioning problem. Okay, so you need to find out the minimum number of cuts. Okay, so here are some examples. I'm going to discuss this problem in detail with the help of examples. For now, let's look over the constraints. You can see the string length is 2000, and we can have a dynamic programming approach, because greedy approach is going to fail over here. We need to check it out all possible cases, right? So we are going to have a O of n squared space and O of n squared time solution, which I will discuss in this video. Okay, so let's move further to understand this problem in detail, how we are going to build up our DP states. Okay, so let's move further. Okay, so let's start from the base case. Like suppose we have the strings like s1, s2, s3, s4, let's say up to s6. Okay, now at a certain state of iteration, what I want to say is, like, suppose we have already find it out all the minimum values up to for these of the states. This is for up to dp of one state, and this is up to dp of 2 state, and this is up to dp of 3 state, and this is up to dp of 4, and so on. This is up to dp of 5. Like if we have been if we have been asked that what is the dp of I, where I is going to, let's say, 5, then we are going to say yes, this dp of I that will give us the value is going to have the minimum number of cuts for the substring starting from, or you can say for the string starting from the beginning up to the I equal to 5. That is from I equal to 1 and up to I equal to 5. That is, we are already having the values of dp of 1, dp of 2, dp of 3, dp of 4, dp of 5 being the minimum value, which is like the number of cuts required to for a substring starting from I equal to 1 and up to a given I. Okay, so this is like we are assuming that we have already find out these dp of values from I equal to 1 up to I equal to 5. Now the thing is, what I have to do is, we are going to find out how we are going to have the this value like a dp of 6 from previously calculated values. As we all know that the dynamic programming approach uses the pre-calculated values. Okay, that's why I have said that at a certain state of iteration, we have already find out the minimum values from dp of like from I equal to 1 up to I equal to 5 for all those dp values. Now we are trying to find out the value of dp of 6 with the help of pre-calculated values. Okay, so how we are going to do that? Okay, so what I am going to have the approach is like you can see that I need to include this character. Okay, so the partitioning can be like for including this character, partitioning can be at this point. If I am doing partitioning at this point, note that a string containing a single character is always a palindrome. Then dp of 6. Okay, so let me write down clearly. dp of 6 must be exactly equal to 1 plus dp of 5, right? Provided like one thing that you need to check it out at every step of iteration, that this there can be possibility that starting from 1 up to 6, like a string is a palindrome, like entire string is a palindrome starting from I equal to 1 and up to I equal to 6 right now. Okay, so this can be a palindrome. In that case, you're going to say yes, our minimum value is 0 right now. We are not going to perform any of the cuts. Okay, now suppose it is not a palindrome, like s1 to s6 is not a palindrome. Then in that case, you are going to have like doing the partition over here. In this case, you are going to write dp of 6 must be equal to 1 plus dp of 5. Okay, you need to take it out the minimum every time. Like the current answer is like this one for doing the partition over here. Now let's check it out. What are the more positions that we can perform the partition? Okay, so let me erase this one also. Okay, so let me erase this one. Okay, now the thing is like you can do the partition over here. Okay, only and only when this string is a palindrome according to the condition, because these all are the like these minimum values we have already find it out. Like we have the dp of 4 being the minimum cuts required to cut a string, like do the palindromic partition from this one to this one. Now we need to do the partition over here to include this character. In that case, we need to ensure that this string of characters being formed from like s5 and s6 must be a palindrome. Then you are going to write 1 plus dp of 4. Okay, and let me write down that this is going to happen only and only when s5 s6, that is the string formed from s5 and s6 must be a palindrome. Similarly, what I am going to do is like let me erase this one also. Okay, yeah, now you can have the partition over here. Provided this entire string must be a palindrome, then only you can include 1 plus dp of 3. And similarly, you can have the partition over here. In this case, like you are going to do this only and only when this entire string is a palindrome. Also, you can do this over here, like you are going to vary your j from I equal to 1 up to I equal to 6. In other words, if I will write down a single formula, it will be like this. Okay, so let me do this one. So it will be like that dp of I must be equal to minimum of dp of I for all those dp of I values, dp of I, and 1 plus dp of j. Okay, now the thing is like you are going to do this operation for a particular j right now, and for those j where I will say for those j, like we are going to do this, you are going to apply this formula for those j. Note that I am varying j from 1 to I minus 1, right? So I am going to do this only for those j where is pal, note that I'm introducing another term, is palindrome j up to this I. Like okay, so I need to write down one thing. This is dp of 1 plus dp of j minus 1. Okay, now the thing is like I will say I will do this minimum operation for those j whose like whose palindrome, like the string is palindrome starting from j to I. Okay, suppose that j is up to this one, like j is over here and I is over here, right? Now according to this formula, what I will do is like if is palindrome of j and I, like starting from the character j, this s4 up to this current one, if it is a palindrome, then you are going to do this operation. Okay, and the operation is minimum of dp of I and 1 plus dp of j minus 1. Note that j minus 1 is this one. As I have already said, we have already calculated those values, and now we are going to calculate the current minimum value by putting partition over various places, right? You need to ensure that whenever you are trying to do this condition, you need to like ensure that you are going to have this condition being true, like like this string palindrome, like the current string is starting from the index equal to j and up to the index equal to I, which is the current position, must be a palindrome. Okay, now you can see that we are going to vary I from 0 to the string length, and also we are going to vary every time, for every I we are going to vary my j from 0 to I minus 1, right? Now you can easily see that this has the time complexity of n square already. Okay. Now we need to optimize this time complexity. Why? Because if we are, how to check that this is a palindrome? Like if we are at a particular j, we will have to ensure that is palindrome j and I must be true. It means that the current string starting from j up to I must be a palindrome. If you are going to traverse it out and check it out, the overall complexity will be around O of n cube. We need to optimize this complexity. Then how we are going to do that? We are going to use like we are going to have a pre-calculation that whether the current substring starting from j to I is palindrome or not. We are going to pre-calculate it. That's why I've written a separate 2D Boolean vector. You can say is pal j and I. We are going to calculate for every ij, where ij varying from 0 to n minus 1, that current substring starting from j to I is a palindrome or not. Okay, the concept I am using is like a matrix chain multiplication. I will explain it out now. Okay, so let's move further. Okay, so previously, what I have said is like we need to do this condition only and only when this condition is going to hold. Okay, like palindrome, like a substring starting from j up to I must be a palindrome. Then I'm going to do dp of I equal to minimum of this and this. Okay, now how to fill up the values of is palindrome? Like we have a Boolean 2D vector is palindrome of n plus 1 size of n plus 1. We need to fill up the dp values. Like if I have like s1, s2, s3, s4, s5, like if I want to fetch the value of is palindrome of like 2 to 4, then it will just check it out that whether the substring from 2 to 4 is a palindrome. Then I can say yes, it is a palindrome. Yeah, if it is a palindrome, then this value will be filled with true. Okay, now the thing is how to find out these values in a O of n square time. Okay, because n is around 2000, so we should focus over n square time. Okay, now the thing is like suppose we have a string like s1 up to s5. Now a single length like a single length substring is always a palindrome. Now the double length substring is a palindrome only and only when these two characters are same. Okay, now what will happen when substring of 3 length, when we call it is a palindrome? I will call this as a palindrome when S2 matches with S4 and the inner substring excluding the lth position and rth position should be palindrome, right? Then only this entire substring is a palindrome. Okay, this is the concept I am going to use. Okay, suppose I will just claim it out that this S1 to S5 is a palindrome, then and like this will be a palindrome only and only when this extreme characters S1 and S5 must be exactly equal, and the substring excluding this first character and excluding this last character, like we have, I'm talking about this substring, this must also be a palindrome. Then only and only I can say that this entire substring is a palindrome. Okay, so the concept is like we are going to use a similar thing as of matrix chain multiplication. We will start from the length equal to 1 and then move further to length equal to 2 and so on. If I will talk about length equal to 4, okay, then I will just go for every substring of length equal to 4. Okay, and for claiming that this length equal to 4 is a palindrome, like I will say that s1 to s4 is a palindrome if and only if if and only if s1 and s4 are same, and s2 to s3 like is pal of s2 is pal of 2, and the another subscript will contain is pal of 2 and 3, must be a palindrome, okay, and also s1 s4 must be equal. Then only I can say that is pal of 1 to 4 is going to have the value as true, okay, like an entire substring from s1 to s4 is going to be palindrome, then this value should be filled with true, okay. In other words, if I am not so lazy, I will write down as is pal of 1 to 4 is a palindrome only and only when S1 is exactly equal to S2, sorry, S4, and I will write down is pal of 2 to 3 must be a palindrome. Like this will have the true value, and this will also yield true, then I can say that S1 to S4 is also palindrome. If I'm talking about S2 to S5, then S2 and S5 must be equal, and is pal of 3 and 4 must be true. Then only I can say that is pal of 2 to 5 is going to hold the true value. Okay, now let's head over to the code to find out the exact solution, how we are going to do the pre-calculation, and how we are going to move further to the best solution for this problem. You can see that n is the string's length, and here is a DP I am going to maintain up to size n plus 1, and initially I am going to fill up with the worst case values. As I have already said, if all the characters are going to be distinct, then the minimum number of cuts that need to be required to partition this palindrome, partition this string, okay, is length minus 1. So I have filled with DP of I equal to I minus 1, okay. Now here is some pre-calculation that I am going to do. Is pal is going to store whether a substring starting from I up to j is a palindrome or not, okay. Now a string of like a substring of exactly one character, like a substring of length 1 is always a palindrome. So you can see I have filled is pal of I and I as true. Now I'm starting for from L equal to 2 up to going up to L less than equal to n, like the entire substring. What I will do is like iterate over every I and pick up a substring of length exactly matching with current length, that is L, okay, like from I to j. And if L is 2, I need to separate this condition, okay. So if L is 2 and those two extreme characters are same, then is pal of ij is exactly true, okay. Otherwise you need to do a simple condition. If this extreme characters are same and the like the value is that is being given by is pal of I plus 1 and j minus 1, that is excluding the boundary characters, if that value is also true, then then only and only we have the current substring being true, like is pal of ij is true, denoting that current substring is a palindrome. Okay, so this is the pre-calculation that I need to do. Now we need to find out the minimum cuts. Okay, so how we are going to find it out? Okay, so starting from I equal to 2, because I equal to 1 will have like we are already familiar with, we have already filled it out the values for I equal to 1. Okay, so I will start for I equal to 2. So is pal of 1 to I, like the entire substring up to the length equal to I starting from 1. You can see that the current substring, entire substring that I need to talk about is already a palindrome. Then dp of I is always 0. Like we are not going to perform any of the cuts. Okay, otherwise start j equal to 2 and it goes up to less than equal to I, and every time increment your j. Now this pre-calculation is going to help us, and I will check it out. Is pal of j and I, like if we perform a partition just behind the jth character, then I need to ensure that the substring starting from jth index up to the ith index must be palindrome. That's why I've checked is pal j and I must be true, then only and only when I need to take the minimum value. dp of I must be equal to minimum of dp of I and 1 plus dp of j minus 1. That is what is the minimum number of cuts up to the up to a index j minus 1 plus 1. That is we are going to perform a cut right now. Okay, so dp of I will store the minimum over all the partition that we are going to do. Okay, and finally return the dp dot back value, that is the minimum number of cuts required to do for this given string. Okay, so this will be our answer. So let's submit this code and check it out whether it is working fine or not. Yes, it is good. So if you have any doubts, do let me know in the comment section of the video, and I will ask the viewers to like this video, share this video, and do subscribe to our YouTube channel for latest updates. Thank you for watching this video.